If approx value of a and b are equal, then to find the solution of this, let a approx value equal to b, so a equal b plus h. Assume. Then put the value in this n plus 1 into a equal b plus h plus n minus 1 into b upon n minus 1 into a b plus h plus n plus 1 into b equal, multiplying these, n into b, n b, n into h, n h, 1 into b, b and 1 into h, h plus n b minus b upon n into b, n b, n into h, n h, minus 1 into b, minus b and minus 1 into h, minus h plus n b plus b. Here b and minus b cancel out, minus b and b cancel out. So nb and nb, 2nb plus nh plus h upon nb and nb, 2nb plus nh minus h. We rewrite this as 2nb plus h n plus 1 upon 2nb plus h n minus 1. Divide by 2nb in denominator and numerator. This become 1 plus h n plus 1 upon 2nb, 1 plus n h into n minus 1 upon 2nb, and this rewrite as 1 plus h n plus 1 upon 2nb, and denominator we taking in numerator as 1 plus h n minus 1 upon 2nb to the power minus 1. By binomial theorem, 1 plus x to the power minus 1 equal 1 minus x plus x square minus x cube and so on. So here 1 plus h n minus 1 upon 2nb whole power minus 1 equal 1 minus h n minus 1 upon 2nb plus h square n minus 1 whole square upon 2nb whole square and so on. Since h tends to 0, so h square and higher power of h as h cube h to the power 4 is tends to 0. So 1 plus h n minus 1 upon 2nb minus 1, we can rewrite this as 1 minus h n minus 1 upon 2nb, and higher power is 0. So by these we can write this as 1 plus h n plus 1 upon 2nb into 1 minus, here value of this is this 1 minus h n minus 1 upon 2nb. Multiplying these 1 into 1, 1, multiplying this and this, h n plus 1 upon 2nb, and multiplying 1 by these minus h n minus 1 upon 2nb minus multiplying these h square n plus 1 n minus 1 upon 2nb whole square. But h square tends to 0, so we can rewrite this as 1 plus h n plus 1 upon 2nb minus h n minus 1 upon 2nb. Taking LCM, 1 plus 2nb h into n hn plus h minus hn minus h minus 1 plus h. So hn and hn cancel out each other. 1 plus h and n 2h upon 2nb. 2 and 2 cancel out each other, so it become 1 plus h upon nb. But we can rewrite this as 1 plus h upon b to the power 1 upon n. Since higher power h square tends to 0, so if we express this become by binomial theorem 1 plus 1 upon n hb plus 1 upon n into 1 upon n minus 1 h square upon b square plus so on. So h square is tends to 0 and higher power of h is tends to 0, so all terms are 0 and it will remain only 1 plus 1 upon n into h upon b. So by again this 1 plus h upon b, its LCM b plus h to the power 1 upon n, and b plus h. At first we assume a equal b plus h, so b plus h replaced by a upon b to the power 1 upon n. So this is equal to a upon b to the power 1 upon n. This is answer.